the amount of data that you need to build your own custom machine learning model often is more than the data you have in your factory, especially for some of the more important problems. So there's always this challenge of how could I do machine learning effectively in the factory when I don't have enough labeled data? Um, that's not an issue with the large language models because they have already been pre-trained, they're mass manufactured, and it is made available now as a component or a building block that you can integrate into your systems. And so we're going to talk in this class only about the large language models, and they have a fairly similar structure, right? Which is they're thinking of them as they're okay, black box. I either download one on my computer, run it on my cluster, one of the open source ones, or I use OpenAI or DeepThink or Gemini or Anthropic or Mistral. They all kind of work the same way. And the interesting thing about them, unlike, I think most other computer building blocks, their native input and output is human readable text, which is kind of interesting. It's like, it also creates a challenge. How do I integrate this into a computer if it's meant to go from like text to text? So under the hood, because these things are all giant matrices of numbers, there's an encoding process where, I start with some human readable text and I've got some fixed input buffer of size. I've got a matrix, I've got an output buffer. So how does the LLM work? I've got something which can take a question, represent it up to some maximum size, run it through this thing, and I get an output that can also be transformed back into human readable text, also of a fixed size. So these things need to work on numbers. So then I need to put encoders and decoders on both sides. So I need to agree how I'm going to take like text and turn it into numbers. I need to then agree how I'm going to take these numbers here, turn them back into text. And now you've got sort of like the end-to-end version of how like an LLM interface works. And, these little token coders, there's nothing magical about them, but each of the large language model providers, decided which one to do. So here's an example of how OpenAI did it. So the word my gets encoded to, 3,656, space favorite, color is red. So it's not necessarily like a word per token, but it's sort of like similar-ish to that. And this is sort of how the LLMs work. They take human readable text and then they generate an answer. And internally they're all numerical, but you've got these little encoders that can let you take text in, a language like English or another language, and then turn it into this input and then get back an output. So they're sort of an oracle box that answers questions is sort of how they're designed. But one of the interesting things, when they got started and the language from large language model was sort of based on this assumption that they're working on text only, on language. But if you're encoding things as numbers, then the large language model doesn't actually know if it came from text or it came from audio or it came from a picture. And so then there was this next wave of innovation where they started playing with different kinds of inputs. And they were able to train these models to take pictures as input, like our eyes, for example, we can see pictures, we also hear things, and then we can read. So most of the latest large language models, they're able to natively take a combination of text, maybe like voice, just directly like recordings or waveforms of someone speaking, as well as pictures. And they natively reason about all of them. So it's not the case that the image is first like pre-processed into a textual description that's fed into the LLM. Like literally the picture itself is shoved in there, as well as the text you gave to it. This is particularly interesting because, there's a lot of cool things in pictures. Think of like defect images from the OI, or think of, problems with situations like loading a machine. Or one of the more interesting ones that I saw is guidance for an operator on how to set up the switches on a particularly complex, HMI for setting up a process. You take a picture of it and then give it to the large language model and say, compare these switch positions to what they're supposed to be for this changeover. And it comes back, looks at the pictures, looks at the switches and says, oh, you got this one right, but this one is wrong. This one doesn't match what it's supposed to do. So a lot of like interesting things that you can do with this little trick. So then when you pick a model, for your large language model, all you're doing is you're swapping out this little box here. So, you've got, and these models come out every like couple months or so. It seems like the different AI labs have them just like waiting, because as soon as one AI lab comes out with one, then within an hour, the next version of the competitor model also drops, which is very useful for us because then it means you don't have to worry about being beholden to any one model. Because if someone's ahead, they're only ahead for like a couple hours, it seems like, which seems like a very fraught position for them to be in, but is useful for us as consumers. But anyway, so all you're doing is you're picking these large language models, and then I guess the other important thing to realize or understand is that the large language model is static. Like, this matrix does not learn, does not change over time. When Anthropic comes out with Opus 4.6, the latest model, that's just a series of gigantic matrix of numbers. When you use it, that matrix does not change. It has no memory of what input you put into it. It's not embedded in the model. It's not added to the model in any way. The model itself is static, which is very different from the machine learning case. If you're building a machine learning model, like those use cases you're putting in there, those labeled examples of data to output, they're somehow, in some complex way, they're embedded and stored in that model itself. So there's a worry like, maybe I'm leaking my data. Maybe I'm leaking what I trained this model on is now part of that model. I don't know how to get it back out. Maybe in the future, someone will figure it out and can get it back out. And so I need to worry about that. That's not how these large language models work. Like, the LLM itself is static. I put in my input, run it through the matrix, turn the crank, get my answer, and then it's done. If someone deleted the logs, there would be no record of how that, of what that happened. Yeah.
So when you're working with you're telling it, right, this is the process or how you do things. Says, okay, yeah, you're in that out of direction starts switching outdoors. So using this compose this conversation.
Yeah, exactly. It's both the pro and the con. So let's talk. Actually, I'm gonna get that right now. So that is true what you just said. The ChatGPT has no intrinsic memory, and every time you use it, it's like complete amnesia. It comes back to how you started. So how can it seem like it's having a multi-turn conversation with you? How can it seem like I'm asking a question, I'm just getting an answer back, I'm asking a follow-up question, and it definitely is the case that in my follow-up question, it knows what my first question was. It's having a conversation. So this is all just a really clever sleight of hand that turns out to be really powerful. So this is what actually goes on behind the scenes. Now remember, you've got this like input buffer, and the input buffers are pretty big, much longer than a single question. So when you ask an LLM or you have a conversation with ChatGPT, what internally happens is, I put in my first question, turn one. I put my question in, hey, what's going on? And it gives me back an answer. So that first time, all it had was my question. And maybe to your point, there's also some secret instructions that are prepended that are called like the system prompt. But they're the guidance that, Anthropic or OpenAI, but how it should generally behave. And you can customize that sometimes. Like, I want it to behave like this, and we get prepended to your question. But now let's say I ask a follow-up question. Actually, behind the scenes, what's going on is my entire conversation up to that point is being replayed back into the LLM again. And the second time I ask question two, what's really being given to it is, hey, the user asked question one, then you get back answer. Then they ask question two, now what should you say? And it gives back answer two. So the way that it has memory is really just by playing with extra space in the input buffer and some external system, usually hidden from you, but sometimes you're in charge of it as well. You are deciding what to include about past interactions to make sure it remembers them. And so, you could do again, turn three. You can keep going on and on and on until you run out of space in the input buffer. So you can say question one, answer, question two, answer, and you can go on. So this is sort of like the key piece about how large language models are customized. They're customized by someone, often you, some of the other people, putting extra things into the prompt in addition to what you think you put there. And that whole thing is then what's fed in, crank is turned, answer comes back.
Yeah, that draws sense that you're just saying all has choose topics. That's one. But is there any other different models that perhaps actually learn and then from the copy?
Yeah.
That necessarily escape on the privacy of Apple stuff.
Yeah.
Privacy software.
So yes and no. So do any of these models like actually learn? So fundamentally, no. All the models are static. Now, some of the model providers like OpenAI or like Anthropic, they'll have a thing they call memory, but really it's just like a background process that's looking at your past conversations and saying, oh, actually, it looks like you asked this question 5 times in the past. Let me choose to save that. And then they'll just add a section here called memory. So the models themselves, like once they're released, they don't improve, they don't change. The only thing that might make them behave differently over time, once the same model is, if the system prompt is changed, so like the instructions that are generally given, maybe they add an extra sentence, or if you have some memories that get prepended to your questions, or as we'll see here, something about like we'll give it tools, and we'll talk about like what that can do. But let me pause. It's a really fundamental point that the LLMs themselves, they're static. They don't learn, they don't change once they're released. That's why they're versioned. So we got like Opus 4.3, then 4.4, or so then 4.5, then 4.6, ChatGPT 1, 2, 3, and 4. And the way to think about those capabilities is when a new model version comes out, you're just basically setting like how good this arrow is. Like how ambiguous or how like vague of a question could I put in the arrow and still get an answer to come out. So let me pause. Yeah, you had a question.
Yeah. So we were talking, I'll try to do it real fast. So we were talking during the break about like when you don't have that much data, and now we're talking about small language models. Have you worked with those?
Yeah, so I have worked with small language models. I guess what I would say is there's times when small language models, like ones you could run maybe on a device or a computer, there's like smaller than the large ones. I don't personally work with them very much because I'm more interested in, okay, what's the most useful thing you can do, or like what's the like most complex thing you can do, and the larger models are more capable. But there's a variety of situations. For example, maybe I must run it on my local device because it is too sensitive. Maybe I don't have access to the internet, so I have to run it locally. And then in that case, now you basically are saying, okay, I've got what's the best model I can use in that situation? What are its capabilities? And then given that, what might I be able to do?
The other thing is about the architecture of the solution.
Right.
So yes, it's aesthetic, but at the same time, like I have been how you saying like ChatGPT 4.1 and now it's 5.2.
Yep.
So then I see the difference, and I think you're going to elaborate about the tools.
Yep.
And then in industrial applications, I mean, I think you're well elaborate about it, but my concern is that because it's modular, that architecture, and you need to be careful when you commit to a solution in your factory.
Yep.
So you want to be that has been my experience, as modular as possible, because things are changing really fast.
Yes. Yeah, no, exactly. So let me just answer that briefly, and then I think some of the questions will come as we get to the next piece here, which is, so on the one hand, it's really easy to swap out the large language model in your architecture, right? It's just they all work the same way. It's just you say, I want to use ChatGPT 5.4 instead of 5.3. The downside, though, is it's like training a new person or onboarding a new person in your process. Like, sure, they're supposed to be able to do the same thing, and maybe this person has 10 years of experience, I don't have 5. But also they come with a whole set of baggage that needs to be evaluated and decide what else was changed with that new model. So it's simultaneously like easy to swap to the new one, but also there's a whole set of questions that need to be answered around how do I recertify or understand what else might have changed? Because there could be a lot of unintended consequences that the new model is like, yeah, generally get better at everything, except maybe I need to ask the question a slightly different way. So I need to figure out how do I even know that things have changed when I swap out the model. Okay, so now let's go to a more interesting one for factors, which is how does the model have access to information about my factory? Because I just told you it was static, and it definitely wasn't trained on your factory's data. Hopefully, it's probably not, unless your factory's data is on the internet, but most likely it wasn't. So then how could it possibly know what the OEE was of shift one when shift one was an hour ago or ended an hour ago and the model was released 3 months ago? Fundamentally can't be in that model. How can that work? So again, it's a sleight of hand, but again, a very useful sleight of hand. So behind the scenes, what's going on is this turn one, what it's saying is, here's my question. Yeah, what was shift one's OEE? But there's also then another piece added. Here are your tools. And the here are your tools are just a structured description of these are the things you're allowed to ask me for an answer to in order to answer the user's question. And in this case, we'll give it one tool, which is, hey, you can query OEE from an OEE database. Call it the OEE database tool. You just tell me the shift, you tell me what you want, and then I'll give you back the answer. So now when you ask this question behind the scenes, the first turn was, well, just wants OEE, here are your tools. And what the model came back with is like, I've got no idea what shift one's OEE was. I don't know that, but you gave me a tool and you said, use this tool and you need to answer this question. So it comes back with a tool invocation, which says, hey, I need to use this tool. Great. Now it's your job to run the tool. The LLM can't run the tool for you. It's just a static box of numbers. So behind the scenes, the harness or yourself or the AI provider is saying, oh, it wanted to run a tool. So let me run the tool. And then let me give another turn. So now it fills in, okay, what was my question? Here's the tools. I said, run the tool. Here's the result. And now you or another system have to run that tool for it, give it back the answer. And then it's like, okay, great. So it asked me if my shift was OEE. I ran the OEE tool. I got back the number. Here's my final answer. And so that's how it's sort of able to interact with the world. It's through giving it a series of tools and then it telling you which one it wants to use, you running the tool for it, and then giving back the results of the tools, and then it has a final answer. So this is sort of like I would say the most common paradigm in which these large language models are used for useful, work in factories. And it all comes down to, okay, what context you provide it, but also what tools you make available to it. And we'll sort of see how people build increasingly more complex use cases out of this. But this is sort of like the fundamental way that they work. Yes.
So how these tools differ from using a let's say a OPX ability and then they data analysis.
Yeah. So it's a great question. So fundamentally, it's similar. There's one really important difference. The really important difference is right here. The fact that the AI model is spitting out the tool invocation it's deciding what parameters to call the tool with. And it's going to be super useful because, for example, and as the models have gotten better, you can do a lot of really cool tricks. So let me make an example here. Let's say this tool was just a really basic one. Just run SQL query, and then the input is the query you want to run. So now what the LLM is really doing is it's actually acting as an ad hoc data analyst. It's writing an arbitrary SQL statement, which is supposed to embed everything it wants to know. You run a database, give back the answer, and it might run a second one or a third one or a fourth one based on what it needs to do. So when it got started, it was, I would say, when the models weren't as capable, you had to give it very purpose-built tools. Ask me for shift one OEE. All you do is put in the shift you want, and I give back OEE. And so it's kind of limited because you really had to constrain what it could do and almost scaffold or hold its hand. But what we'll see in an example is the latest version of models literally is just run SQL query or write Python script yourself. I'll run it for you and give you back the answer of what it said. And it's become much more capable of using more open world style tools, which means it can control its own investigation a lot better than it used to be able to. And that's the primary difference. Okay. So then all these LLM based tools at the end of the day, they work kind of like this, in this sort of flow. There's a question of what tools they're given. There's a question of what is prepended to the questions. And there's a question of how many turns they're allowed to run before they are forced to give you back an answer. Sometimes it's one, sometimes it's 50.